Okay, everybody, so I'm going to start working through these problems just so you can make sure that you're doing it right as well. And what we're looking at here is the first one where you can just split it up and do each term separately, okay? So I'm going to take the 3 and kind of ignore it, and then I'm going to take the x and add 1 to the power, so it's a 5, so 5 plus 1 is 6, and put that over that same number, okay? And then minus the antiderivative of a constant is just 3 times x, and then plus c. Now, if you can clean this up, you do want to clean it up a little bit. So I'm going to reduce my fractions, and I'm going to write my final answer just like this, and you are finished with number 1. Number 2 is one of the kinds where before you can use a power rule, you really need it to look like x to some power. And so I don't like the radical. So I'm going to get rid of the radical by writing this as x to the 1/3. And then I'm going to take an antiderivative of that. So to do that, I'm going to add 1 to the power. So 1/3 plus 1 is actually x to the 4/3. I'm going to put this over 4/3. And I'm going to recopy the 2 that was in the front. I need to make sure I bring that coefficient back. And then I'm going to clean that up. And when you have a fraction on the bottom, it's going to flip and multiply. So really this is 2x to the 4/3 times 3/4. So if I'm multiplying by 3/4, then that's going to be 3x to the 4/3. Let's see, 3/4 over 2. I believe that's correct. Yeah, that's right. Okay, so then you're finished with that one. Okay, this is another one you want to rewrite because it's in the denominator, and that's not a great thing. So the first thing I'll do is rewrite this as x to the -4th. So I've taken it out of the denominator, and now I can power rule it. So the antiderivative power rule is going to be adding 1 to this, which makes it a -3, over that same number of -3, and then plus c. Now this can be cleaned up because you don't ever want to leave a negative exponent. So this term needs to go back into the denominator. So there'll be a 1 left on top. This goes back down with the -3. Oh, my bad. It's now a +3, sorry. And then plus c. Okay, so that's your final answer there. Same thing, we're going to do the same thing here. First you rewrite it. The 6 just stays a 6, okay? And instead of x squared on bottom, it's now going to be x to the -2nd, and I'm going to power rule that. So recopy my 6. This is x to the -2 plus 1 is -1 over -1. And when I clean that up, it's going to be a -6 over, once again, bring this back down to the denominator, plus c. And last but not least, something like this, you're going to want to rewrite. Now, there's a 5 on the bottom, and you just keep copying that through the problem if you like. You don't need to worry about it too much. So right here, we're going to have x to the 3/4 over 5. And I'm going to actually show you something else. If you don't want to mess with that 5, remember there's just a 1 in front of this x. You can always take that coefficient of 1/5 and move it to the front of the integral, or the integrand. And then this is all you have to worry about doing a power rule. And you could just bring that back later. That's what I usually do. So when I do this and I power rule it, I'm going to add 1 to this. So when I add 1, it looks like it's going to be 7/4. And then it's going to be over 7/4. Well, instead of writing over 7/4, when I multiply by the reciprocal, it's going to end up being 4/7. So this is a nice trick to save time. If you know it's going to be a fraction on bottom, go ahead and flip it and put it out front. Now I can bring back this 1/5 that was here and write my final answer. So it's going to be 4 over 35 x to the 7/4 plus c. And that is how you do those problems.